Hello, grade 10 students. My topic this time is about the measures of angles formed by tangents and secants. I will be discussing the different theorems and examples. Theorem number 1, if a secant and a tangent intersect on the circle, then the measure of each angle formed is 1/2 the measure of intersected arc. Here in the illustration, the secant line is secant BC and the tangent line is tangent AD. The angles formed are angle ABC, which is this angle, and another angle is angle DBC, which is this one. For angle ABC, its intersected arc is this arc BC. And for angle BEC, its intercepted arc is this angle. This arc, which is arc BEC. According to the theorem, the measure of angle formed is 1/2 the measure of its intersected arc. So let's say if the measure of angle ABC here is 20, then the measure of its intercepted arc is 40 degrees. And on the other side, let's say if the measure of this angle is 160 degrees, then the measure of its intercepted arc is 320 degrees. That's how we are going to apply theorem number 1. To apply theorem number 1, let's have this example. Find the measure of angle ABC. This one is angle ABC. If the given arc is equal to 102 degrees. 102 degrees is arc AB here. Our goal is to look for this angle, but before we look for this angle, we should find first the measure of this angle. If the intersected arc is 102, then this angle is 51 degrees. So to get the measure of this angle, simply divide the measure of arc by 2, since the measure of this angle is twice the measure of this intersected arc. Now, if this angle is 51 degrees, simply subtract it from 180 degrees. Why 180 degrees? Because this angle and this angle are supplementary because they share the same straight line here. So, for us to find the measure of this angle, simply subtract 51 degrees from 180 degrees. And the answer is 129 degrees. Therefore, this angle measures 129 degrees. Example number 2, still the application of the first theorem when secant and tangent intersected on the circle. So here, the secant line is secant PS and the tangent line is tangent QR, and they intersected on the point on the circle P. Point P on the circle. So here we have to find the measure of angle RPS. So RPS, this one is angle RPS. This is the one that we have to look for. And then the given are arc PT. PT is here, which is 114 degrees, and arc TS, which is this one, equivalent to 136 degrees. Now we have to look for this angle RPS. So we have to know first the measure of this arc. And to look for the measure of this arc, simply add the two given arcs, which is 114 plus 136. Then it is equal to 250 degrees. Now that we know that the measure of one circle is 360 degrees, simply subtract 250 for us to know the measure of arc PS, this one. So 360 minus 250 is equal to 110 degrees. Therefore, this arc is 110 degrees. Applying the theorem, simply divide the measure of this arc by 2 for us to get the measure of this angle. So 110 divided by 2 is 55 degrees. Therefore, angle RPS is equal to 55 degrees. Theorem number 2, if two seconds intersect in the circle, then the measure of the angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Here in the figure, the 2 seconds are secant AD and secant BC, and they intersected inside the circle. This is the point of intersection, which is inside the circle. According to the theorem, the measure of the angle formed, which is angle 1, is an angle formed by the 2 seconds. To get the measure of this angle, simply add the measure of its intercepted arc, which is AC, and the intersected arc of its vertical angle. So this is the vertical angle of angle 1, and its intercepted arc is arc BD. For us to get the measure of angle 1, simply add the measure of AC plus BD and then get 1/2 of it, or simply divide by 2. The same thing, let's say another angle formed by the 2 seconds is angle 2, this one. To get the measure of this angle, simply add the measure of its intercepted arc, which is arc AB, and another arc here, arc CD, then divide by 2. Again, add the measure of the two arcs, arc AB plus arc CD, divide by 2, then the measure is equal to the measure of this angle 2. Let us apply theorem number 2 by answering this example. So here we have 2 seconds, secant AC and secant BD, and the 2 seconds intersect inside the circle. We have to look for the measure of angle 2, this one, if the given arcs are 30 degrees and 20 degrees. So again, arc BC is given, which is 30 degrees, and arc AD is given, which is 20 degrees. Based on the theorem, for us to find the measure of angle 2, simply add the measure of the two arcs and then divide by 2. So the two arcs are 20 degrees and 30 degrees. Add the 2 and then divide by 2. Let's continue this. 20 plus 30 is 50 degrees. Divide by 2 equals 25 degrees. Therefore, the measure of angle 2 is 25 degrees. If you will be asked for the measure of angle 1 here, angle 1 is opposite or vertical angle of angle 2, then the measure of this angle is also 25 degrees because opposite angles or vertical angles have the same measurement. Let's have another example here to apply theorem number 2. So here, 2 seconds intersect inside the circle. So we have secant FH and secant EG, and they intersect here in the circle. We have to look for the measure of angle X. This one is angle X with the given FG, arc FG, this one 88 degrees, and another given the measure of arc EH, which is 76 degrees. For us to look for the measure of angle X, we have to look first for the measure of this angle, because the given arcs are the intercepted arcs of this angle and its vertical angle. So let's say this is angle Y. So let's solve for angle Y. The measure of angle Y is equal to the sum of the two intercepted arcs divided by 2. So it means 76 degrees plus 88 degrees divided by 2 equals 76 plus 88 is 164. Divide by 2, the answer is 82 degrees. The measure of angle Y is 82 degrees. So let's write here 82 degrees. This one is also 82 degrees. Now, let us solve for the measure of angle X. For us to get the measure of angle X, simply remember supplementary angles. Why supplementary angles? Looking at the figure, angle X share the same line. So this is the line, EG is the line that tells us that angle X and angle Y are supplementary angles. What does it mean? If two angles are supplementary, then the sum is 180 degrees. Meaning to say, if you will add angle X and angle 82 degrees, the sum is 180 degrees. Now that angle X is missing, simply subtract 82 degrees for us to find X. And that is 180 minus 82 degrees. The answer is 98 degrees. And this is the measure of the missing angle, which is angle X. So we're done in this example. The measure of angle X here is 98 degrees. Now, the last theorem involving the measure of angle formed by the two secants or tangents, we have theorem number 3. If two secants, the first illustration, a secant and a tangent, second illustration, or two tangents, the third illustration, intersect outside. So if you notice, all the combinations intersected outside the circle. Then the measure of the angle formed is 1/2 the positive difference of the measures of the intersected arcs. Here, if the two lines or the segments intersected outside, then we have to subtract the arcs and then divide by 2. The same thing in the previous theorem, but the only difference there is we have to add in the second theorem. So add the two arcs, then divide by 2 if the two lines intersected inside the circle. And then we have to subtract the two arcs if the two lines, whether secant-secant, tangent-tangent, or secant-tangent, intersected outside the circle. So here, let's say, to find the measure of angle A here, simply subtract CE, arc CE minus arc BD, then divide by 2, and that's the measure of angle A. For the second example, to get the measure of angle A here, simply subtract arc DC minus arc BC divided by 2 equals the measure of angle A. And the last, to get the measure of angle A, simply subtract again arc BDC minus arc BC divided by 2 is equal to angle A. So that's the definition and illustration of theorem number 3. Example number 5 is an application of theorem number 3. So here we have two secants that intersected outside the circle. We have to find the measure of angle X. Given the two arcs, 120 degrees and arc 50 degrees, look for the value of angle X. Simply apply the theorem, subtract. For us to get the measure of angle X, it is equal to 120 degrees minus 50 degrees divided by 2. Let's solve. 120 minus 50, 70 degrees, divided by 2 equals 35 degrees. Therefore, the measure of angle X here is equal to 35 degrees. And now for the last example, applying the third theorem, we have two secants here again that intersected outside the circle. we have to look for the measure of x. But this time, this x is the measure of arc because the angle here is given, which is 62 degrees. Another given is the measure of the bigger arc, which is 141 degrees. Let us apply still the theorem. Let's come up with the equation. So here, let's start with the measure of the angle, which is 62 degrees. It's given. Then it is equal to 1/2 the measure of the two arcs, the difference of the two arcs, which is 141 minus x divided by 2. Let's solve this. Multiply both sides by 2. Then this will become 124 is equal to 141 minus x. So this will be cancelled. Let's exchange the position. Transpose negative x to the left. It will become positive x. Transpose 124 to the right. It will become minus 124. So 141 minus 124 is equal to 17. The value of x is 17 degrees. Therefore, the missing arc, the measure of the missing arc x is equal to 17 degrees.